For this training video, we will discuss conjugate heat transfer. This tutorial covers the basic steps required to set up a flow analysis, including heat conduction in solids. So this example will discuss about analyzing flow and heat conduction within the electronic devices. And also we will be doing internal analysis that we could use for our CFD simulation. So first, we have to open the Solidworks model, conjugate heat transfer, and we have to copy this on a different folder, which is we are using as our desktop. So this is the assembly of the conjugate heat transfer. This is an enclosure. So as you can see, we have this fan that forces the air to the enclosure and goes out in here area in this area. So these are the parts. We have the heat sink, PCBs, small chips, power supply, capacitors, main chips, and the motherboard. So we have to prepare the model. So as highlighted here, it is not necessary to use a detailed fan for our simulation. So we have to suppress the fan and the screw. And since this model already have this leads, so we have to activate the leads. So unsuppress. So as you can see, the leads already came out. Have to check if all of the leads are in place. So you can see these are all in place, the leads and the outer leads. So we have to make sure that these leads are already showing, because we cannot perform our internal analysis if something is open in our model. Okay, so since we already unsuppress all the leads, we have to go to the flow simulation project. So first of all, we have to open the project wizard. So open project wizard. Then we have to select and rename it to inlet fan. Then click next. So for this training manual, we have to make a new a new units, which is USA Electronics, to suit up our analysis. So using the default, which is the SI, and we have to rename it to USA, and we have to specify the units as indicated in the manual. So this is a special setup of units based on this. For example, here for length we have to choose inch. So, but for me, I have already set up it here. So we have to use USA Electronics. So we have to use fit as indicated. Oh, it's we have to use inch. So I have to go back here. No. So I have to use inch. Then next is we have to go to the heat group. Select watt square meter Kelvin. So let's go to the heat. So select watt square meter. So once we set up that, let's go to the internal analysis. Then select heat conduction in solids. since we will be doing heat transfer. Then we have to select our gas, which is air. So after that, we go to the fluids, which is air. Add. Then next, let's select the default material, which is the alloy, which is stainless steel 321 as our default solid. So this is necessary in doing internal analysis or CFD analysis, and we have to specify a default material. So we have to select here, but later we could specify different materials on a particular part. Since we are doing heat transfer, we have to select from adiabatic and change it to heat transfer coefficient, and we have to specify the value of 5.5 watts per square meter Kelvin, and the external fluid is at 50 degrees Fahrenheit. Okay, then 50 degrees Fahrenheit. Alright, after setting up, you have to select the initial value to 50 degrees Fahrenheit. Then the initial solid temperature at 50 degrees Fahrenheit. Okay, then click finish. Now we have the model of our CFD simulation, which is the inlet fan. So we could see the computational domain is inside the enclosure. Now, first we need to specify the fan that we will be using. So using flow simulation, insert fan. So let's look for the model of the fan. So first we have to select where will be the fan will be located. So there's three types: external inlet, external outlet, and internal fan. So since we will be using external inlet fan, then select this face, select other, as it has been highlighted by the orange face. We have already selected the face of our inlet fan, and let's look for the axial POPs-T 412 fan type. This is already predefined. So axial POPs-T 412. And you have to select and input the thermodynamic properties at 14.7 psi and click OK. So let's check if so it's already 14.7. Okay, so this is our external inlet fan. Next is we have to specify the boundary condition. So since we have the inlet fan, the air that is coming out of the inlet fan should go out. So we have to specify where will it go out. So let's insert boundary conditions and select environment pressure as our pressure opening. So select this one, then select pressure opening. Basically, we could do this system, select other, if you can find out. Uh, let's move it around here. Then select other. So you can see it has been already highlighted. Select other again. So we have to select, basically we have to select three faces, select other. Okay, so it has been highlighted as shown, and select environment and 14.7 psi, 50 degrees Fahrenheit. Okay, then let's go back to the manual. So we have to specify the heat sources. So we have to specify, first is the main chip. The heat generation rate is about 5 watts. So heat sources. So let's look for this one, volume source. So volume source, and look for the main chip and input 5 watts. Rename it to main chip. Then next is capacitor. So the temperature should be 100 degrees Fahrenheit. So insert volume source, select the capacitors and 100 degrees Fahrenheit. Insert volume source. So select capacitor, select temperature 100 degrees Fahrenheit. Okay, so rename it. Okay, next is the small chip, which is generating about 4 watts. Right click, insert volume source. You have to select 8 small chips. So control. So we have to shortcut selection of small chips. So as you can see, it was stated to be 4 watts. So rename. And lastly, insert volume source, power supply, temperature 120. Alright, so after setting up, we need to specify our solid material. So for our solid material, we need to input in our database a new material, which is tutorial PCB and tutorial component package. Okay, flow simulation and engineering database. So let's look for the engineering database. So here, where is the engineering database? So this one is the logo. Okay, so under the material, there's already a pre setup materials. So what is stated here, you have to select to go to solids and user define. So solids and user define. So we have to create new. What is the new material? Tutorial PCB, tutorial PCB, and the value is 1120 kilogram cubic meter. Specific heat is 1400 joules. Isotropic 10 watts. Melting temperature is 390 Kelvin. So let's specify the melting temperature. Okay, so once done, save. So we have a new material. Another one is, so what's the material? Is tutorial component package, copy. The value is 2000 kilogram cubic meter at 120 joules kilogram. 0.4 watts. Melting temperature is about 390 Kelvin. Alright, click save and check. We have the two materials already. And close. Save. Okay, next is specify the solid material. So first is we have to set up the motherboard, the PCB1 and PCB2, and select tutorial PCB. So let's select material, solid material, insert. So predefine, user define, tutorial PCB, and look for PCB1, PCB2, and board. And we have to select for the main chip, small chip tutorial component package under user define. So insert solid material, user define, tutorial component package. You have to select the main up to the small chips. Alright. Then heatsink is made of aluminum and the lids are made of insulator. Insert solid material, redefine metals aluminum, and look for heatsink. This one. Insert solid material, redefine gases and minerals, insulator, and look for the lids. And under the derived pattern, alright. Now we have this setup. So we have to remove lids, insulator, heatsink, aluminum chips. Heatsink, lids, chips, and save. Okay, let's set up the goals. So we have to set up the volume goal, max temperature of solid 1. Okay, so insert volume goal, select the small chips, and temperature of solids. Okay, insert volume goal, and you have to select small chips and temperature, solid. Set average, max temperature of solid. So rename it to BG max temperature, small chip. So we have to repeat this for the main chips. Insert volume goal, select temperature solid, max, and select main chip. Rename it. And you have to specify surface goal for the static pressure average. We specify inlet lead, static pressure inlet, and we will rename it to static surface goal outlet mass flow rate. So let's select external inlet fan goal, insert surface goal, static pressure, average. Then right click again, insert surface goal, select the mass flow rate. Okay, we have the surface goal mass flow rate. Let's go to the insert global goals and select static pressure and temperature fluid. Static pressure and temperature fluid. Insert global goals, static pressure average, and temperature fluid average. Okay, so we have to double check GGAV static pressure, GGAV temperature fluid, SG inlet AV static pressure, SG outlet mass flow rate, VG chip max temperature, and VG small chip max temperature. Okay, save. Then we have to correct the geometry resolution to consider the gap size of the heatsink. 0.1. So click global mesh, click this one, select the minimum gap size 2.1. Then we will run the calculation. Save. Then run. So when the solver is already finished computing our CFD simulations, we'll discuss how to set up the results. Okay, the solver is already finished. We'll close this one. So we have to view the results of our analysis. So this is the expected results as shown here. So let's visit our simulation. So go to the results, code plot, insert, select all, show. So you can see these are the values. So 14.69, 61.63, 14.69, 071, 93.63, 90.72. So our results is a bit higher for the small chips and the PG chip max temperature. GGAV temperature fluid is about 61.63. This, for example, this one is 60 for, and the static pressure 14.696. So we have no difference for this one except for the heat transfer. So this may be a different version of Solidworks. So you have this one, but almost similar, closer to the results that we have, but a bit little bit higher. So I can see the small chips is hotter than the main chip. Let's see. So you can see that the maximum in the main chip is 88.5 degrees Fahrenheit and the maximum temperature over the small chip is 87 degrees Fahrenheit. Okay, let's see what happened. Then after that, we set up our flow trajectory. So we have to select first the inlet, which is the external inlet one. Set up flow trajectory, insert. Then as stated, we have to set up at 200 points and use bonds and use the parameter as what parameter we're gonna use is the velocity. So use bonds, use parameters as the velocity. So number of bonds 200. Then we will have our flow trajectory. You can see this one. So you can see we should expect this one, this model. So if we will run this one, this is how the fluid flows inside the enclosure. Okay, edit again. Let's change this one, cut plots, and insert. Okay, what's this one? Stop, hide. Let's go to cut plot, insert. So since our focus is the top part, we don't select this one. Select, need to select a plane. XY plane. 5. We select. Okay, so we have to select temperature of fluid. The temperature. Okay, so we have to select velocity and the number of levels. So select velocity. Number of levels should be 30. Alright. But this one I did not select the mean and maximum velocity at 10 feet per second, and I did not set up it contours and change the velocity. So let me correct this one. Contours min max velocity is about 0 and 10. Alright, so we have to select the vector, I think, in order to have the similar orientation for this simulation. This one, it uses a vector. So, okay, destination, then change it to 0.3, then select temperature of fluid. You can see this is where the flow is. So we are a bit higher on our simulation. So let's go back to the surface plot. So let's select, right click surface plot and select the main chip and the heatsink and small chips and set to the minimum 50 to 120 degrees Fahrenheit. Let's hide this. Let's go to the surface plot, insert. So let's select heatsink, the main chip and small chips, and select temperature of solid 50 to 120 degrees Fahrenheit. Temperature of solid 50. So you can see this is the picture. And now let's repeat the same process to power supply and capacitor. Insert the surface plot, power supply 120, and another one for the capacitor. Let's select the capacitor, pressure solid 5120. Okay, so based on these results, we'll see that the temperature of our components are, for capacitor about 100, for the heating is about 70 degrees Fahrenheit, for the small chips is about 90, while for the main chip is about 90 degrees Fahrenheit, and for the power supply is 120 degrees Fahrenheit. So using this simulation, could see that The temperature of our solids will be illustrated using this simulation. You'll see how much the components are heating up. This one. So if your chips are about, let's just specs at 70 degrees Fahrenheit, then you should improve your inlet fan to improve the temperature of the main chip. And if your capacitor is just specs about 90 degrees Fahrenheit, and you should improve as well the circulation of your inlet fan, or improve the opening of the lids in order to correct this one. So this is how you do simulation for the conjugate heat transfer. So that's all. Thank you.